Hello boys and girls, my name is Scott and we're going to solve the self-dividing numbers problem on LeetCode today. This is a pretty straightforward and simple problem which we can use with basically a brute force approach. We can be a little bit clever in the way we actually determine if a number is self-dividing or not. That can save us a little time though. Let's talk about the problem definition. A self-dividing number is a number that is divisible by every digit it contains. So we get an example here. 128 made up of digits 1, 2, and 8, obviously. 128 mod 1, 0. 128 mod 2, also 0. 128 mod 8, 0. So 128 is a self-dividing number. Self-dividing number not allowed to contain the digit 0, obviously, because can't divide by 0. Computer will explode. So what they're going to do is they're going to give us a left bound and a right bound. And we're going to output all the self-dividing numbers in that range. So for left bound being 1, right being 22, here are all the self-dividing numbers in that range. Next thing to note is single digit numbers are all going to be self-divided numbers, right? And then for the double digit numbers where it gets a little more interesting, 11 obviously divided by 1 and 1, 12 divisible by 1 and 2, 15 divisible by 1 and 5, 22 divisible by 2 and 2. That is all there is to it. Let's jump into implementing it. All we really need to do in this problem is loop from the bottom of our bound to the top. First off, let's set up a list of integers to return. Called it SDN for self-dividing number. And we're just going to start our loop with an integer I. We're going to start it at our left bound. We're going to keep looping while we're less or equal to our right bound, incrementing I. And all we're going to check is if is self-dividing number of I. And we're going to write the is self-dividing number function in just 1 second. Self-dividing numbers add I. And down here we will return our self-dividing numbers. So let's write this is self-dividing number function because it's doing all the work here. Set up as Boolean is self-dividing number. Going to take in an integer which we will call I. So there's a couple different ways to do this, as with just about anything in software engineering. A lot of people will jump to taking the integer to a string and then parsing each character back to an integer. They can get really slow and really nasty. So we're going to be a little more clever in the way we do it. Set up an integer modulo, and initialize that to 10. Integer dividend, and initialize that to 1. And then we are going to loop while the dividend is lesser or equal to our input value. And I'll explain a little bit what this is actually doing when we get it all set up. We're going to get a divisor, which is going to be I modulo modulo. Got some double modulo stuff going on there. It's a little bit of a joke for you. Not actually double moduloing anything. Just taking I modulo that variable called modulo. So if our divisor is 0 or I modulo divisor does not equal 0, we're going to return false. And then we will update our variables. Modulo times equals 10. And dividend times equals 10 as well. Alright, and if we hit the bottom of the loop, we will return true. And that is all for the implementation of this problem. Let's talk really quick about what is going on in this is SDN, is self-dividing number function. So we set up modulo and dividend as 10 and 1 originally. And then we're looping while the dividend is less or equal I. So let's talk about what this divisor variable is going to be. The first thing we do is take I modulo the modulo variable. It starts at 10, okay? So when it's originally 10, what is, let's take 128. Let's take 128 as our example. We're past 128 in here to I. What is 128 modulo 10? It'll be 8, right? It'll be 8. So in our first iteration of this loop, we will get the digit 8. Okay, so that's our first digit, and then we're dividing by dividend, which here is just 1, so it'll be 8 divided by 1, which is 1. So in our first loop, if this is past 128, we've gotten the digit 8. And then what we're checking here, if the divisor is 0, what's that saying is if the digit that we got out of the number is 0, or I, the number passed in, modulo divisor does not equal 0, meaning the number passed in is not divisible by the divisor. It's not divisible by the digit that we got out. Does not equal 0, return false. And then all we're doing to update our variables, modulo times equals 10, and then div times equals 10. So let's say we're back up in this loop again. We've been passed in 128, and modulo is now 100, dividend is now 10, because they both got multiplied by 10 down here. What is this divisor going to get? I should have named this probably digit, be a little bit more intuitive, because it's just the digit that we're pulling at each spot in the number. Well, I is still 128. What's 128 modulo 100? 128 modulo 100 would be 28, right? Okay, so that's good. It's a step in the right direction. We've got 28 now. So this is going to result in 28. Again, 128 modulo 100 will give us 28. Now this is where dividend comes into play. Now dividend is now 10. 28 divided by 10 in computer math is 2. So that's how we've extracted this middle digit. You know, we passed in 128, we extract the middle digit that way. And then again, this just makes sure that the digit that we extracted is not equal to 0. If it is 0, it's going to be false. And that the digit that we extracted, divisor again, is actually dividing the number passed in, 128. And then we will do this times equals 10 again, and it will continue on that way. So what this is doing, so the key to this whole little algorithm here is by doing the number passed in, which is I, modulo, this modulo value we have set up, that will give us the digits that are less than this value in place. So when we did 128 modulo 100, what did we get? We got the tens value and the hundreds value for the digits. We got 28. I'm sorry, obviously that's not right. We got the ones and the tens, right? So 128 in the ones digit place is 8, in the tens digits place is 2. By taking that modulo 100, we got 28, which is good, but we actually needed 2. So then we divide by a factor of 10 to get to 2. So that's how this works. And then this is just making sure that the digit we pulled out is not 0 and that it actually divides the number that we're trying to divide. If it doesn't do those things, it will return false, elsewise it will return true. So simple algorithm. Let's run the code and then submit the solution just to make sure this actually works. Looks pretty good. And let's submit the solution to make sure everything goes through. And accepted. Cool. So yeah, simple problem. Whenever you're doing some integer manipulation like this, just think, can I use the modulus and the divider operator to manipulate the number the way I need to, instead of going to string, getting characters and all that. That's very messy and it gets very slow very quickly. So that's it for this one. Quick, simple problem. Thanks for watching, and we'll see you later.